So guys, welcome you all to this video. Here we are going to start Cauchy's root test, and this is one of the very important tests regarding this chapter of series. So first of all, what is the statement regarding Cauchy root test? It says that suppose we have a series an be a series of positive terms, and let rho, what is rho? Rho is nothing but the limit of an whole to the power 1 by n, correct? That is nth root of an, and take the limit as n tends to infinity. That is your rho. Then this test says that if rho is less than 1, then the given series will converge, and if rho is greater than 1, then the series will diverge. Fine. And no conclusion can be done when this rho is equal with 1. And that is very straightforward statement regarding Cauchy's root test. And whenever we have some you can say some typical type of problem, then we will use this Cauchy's root test, and we will also deal some problems, and from there you will get the flavor that in which cases we should use this test, correct? So let's go to some problem and try to solve those questions using this test. First of all, we have use root test to determine convergence. We have this series. You can write this series like this way. Okay, you have 3 by 5 plus 3 by 5 square plus 3 by 5 cube plus so on. So that is nothing but a geometric series with common ratio less than 1. In fact, here the common ratio, it is 3 by 5, which is less than 1. So by that proposal, you can immediately claim that the given series, it is convergent, and you can certainly find the sum of this series. But here we are interested to use Cauchy's root test and to verify the convergence. So how we approach? We approach like this way. Simply we consider here the an, that is an equals to, in this case, 3 by 5 whole to the power n, and just use the 1 by nth power and take the limit as n tends to infinity. You will find that it is 3 by 5, which is less than 1, and this is nothing but your rho. So rho is less than 1. So by that root test, you can immediately claim that the given series, that is summation an, it is convergent. Fine. Alright, now your job is just to use that statement to verify next two, that is B and C. Just try for this B and C, correct? And if you are interested for the proof, obviously there are some standard books and you can immediately follow. Now to use Cauchy root test, you have to know some certain non-exponential rules. Okay, rules for non-exponential, and that is, you have, suppose you have a positive constant, that is c, and c to the power 1 by n, and take the limit as n tends to infinity, you will find 1. That is limit of c to the power 1 by n, that is 1 as n tends to infinity. Then limit of n to the power p by n, here also you will find limit as 1. Okay, similarly you have the formula for log factorial n, that is factorial n to the power 1 by n, it is going to be infinity. Then you have another formula, that is n to the power 1 by n, take the limit as n tends to infinity, you will find infinity. So these are some formulas and rules for you, and by which you can immediately claim for certain series whether that series is convergent or divergent using root test. Correct. For that, there is another problem, like you can solve this first problem using that an equals to 1 by 5 whole to the power 1 by n and an to the power 1 by n in fact, and you will find this fellow, and as n tends to infinity you will get 1 by 5. Correct. So it is less than 1, as I have done here. You can immediately check it from there, that an equals to this fellow, and as n tends to infinity with an to the power 1 by n, you will find 1 by 5 which is less than 1, so the series will converge. Similarly, you have for that summation tan inverse n to the power n, you can use this same test and you will find pi by 2 which is greater than 1, so it is divergent. Correct. Thus I have listed here a number of questions, like from 1 to 22 number problem. You can use root test to find or to check whether the series is convergent or divergent. So I expect that you will try these questions in your copy, and if there is any problem regarding these questions, then let me know in the comment section and I will give you the solution.